Okay, so there's a little discussion here about how you compute probabilities, right? And this is just, you just take this as a given for the purposes of the problem. And that is that probability, if you're looking at a particular little area, right, that's at a certain location, is area times that function. That's just the rule, and this is how probability density functions work. And if you, I don't know if any of y'all have seen probability density functions before. Okay, so that's just a given. So it asks us, let's find the probability that our dart will land in. We've got this rectangle that's got a bottom left corner and a top right corner and grand total. I want to add up all the little probabilities. So let's draw the picture. There we are. So the bottom left corner is at -1, -1. I'm going to give myself more space than that. -1, -1. Top right corner is 3, 3. Not hard to persuade yourself, by the way, that our domain then is -1 to 3 cross -1 to 3. All right, this is notation. Is everybody happy with that part? Okay, so now we are given that the probability of the dart landing, there, somewhere in that is going to be, well, whatever the area of this is, area times P. So now let's ask, does this question conform to our rules about double integrals? And, can I answer the question at hand with double integrals? Well, I've got a domain, I've got this integrand thing. Does probability accumulate? Is the probability of hitting this region the same as the sum of the probabilities of it hitting each of the little small pieces? Well, yeah, sure. If it's going to hit in this large rectangle, it's got to hit exactly one of those little pieces, right? Is everybody happy with that part? Next question, on any little piece of area, is the probability equal to size times some function? Well, yeah, that's exactly what it says here. That's this given that probability is a product of area and this function. So it's explicitly telling us that it satisfies that property that's required. So what that means is I can represent, and by the way, our domain here, I guess we've decided to call this D, and that's fine. Is that whole thing. So the grand total probability is going to be a double integral over that domain of P of xy dA. Does that make sense, John? Everybody else okay with that? Okay. And all the question asks us to do is, it says, write out but don't evaluate. So we don't need to evaluate this double integral. Good news, because at this stage we couldn't evaluate double integrals. And so this is all we need to do.
So we don't need to write like the...
Oh, I'm sorry. Yeah, I probably really should stick that formula in there. Sure. That should go there. So let's see, what is that? 3 over pi. Yeah, all right. And maybe I should even, yeah, sure, -1, 3. Sorry. That's our range of values of x. -1, 3. And then, I've already forgotten. Let's see here. 3 over pi. Yeah. That is that what it was? Yes. So yeah, that'd be better. Yep. All right, everybody happy? Okay. All right.